All right. Some housekeeping this morning. Looking at the week 5 announcement. We are starting chapter 2 today. And your first exam is due Friday, September the 15th. You'll be taking that exam in the ACE testing center. My understanding, I heard yesterday that they were closed. They were opened a little bit later. I didn't see any announcement for that. But if they aren't open, I'm sorry, they're supposed to be open from 8 to 5, but there is a limited staff that mans the testing center. You might go out on Redlands Jobs and see if they actually have openings for jobs if you're interested in a job. Because of that, they may be closed during times when they're normally open, but I'm trusting that they're open from 8 to 5 the next few days. And then Friday from 8 to 4, they're open. You do need to get there 2 hours prior to closing, so you'll have plenty of time to take your exam. And there was another one of my classes took their first exam in the testing center. And I am the most directionally challenged human being on the planet, and I am not kidding you. Back in the days before cell phones, I decided, and this is before oh gosh, I'm showing my age, before the Kilpatrick was in, I decided that Christmas, I was going to go to Quill Springs Mall and do some Christmas shopping. And I left Quill Springs Mall, and instead of turning left, I turned right. So instead of going to Memorial, I went to Edmond Road and got in the dark, completely and totally lost. So if I don't know my left from right, which I don't, and get completely lost, I did figure out it was Edmond Road. And I'd been on the Edmond Road before because I used to travel to UCO. So I actually kind of knew where I was going, and I actually got myself home. But I'm directionally challenged. But the testing center is that way. That I do know. That's south, that's north, that's west, that's east. I got it down. The testing center is right there. So you walk out of this building, take those stairs over there, go across the breezeway into the building, go to the stairway, go up to the second floor, and then walk north. Of course, you can't walk south because there is when you go up those stairs, there's a wall there, right? Nothing there. So you got to turn and go that way. It's the only way you can go. And there's a sign outside the room that tells you where the testing center, that it is the testing center. The tutoring center is right next door, correct? So it's there. I had students say, but no, that's the baseball field that way. That's the baseball field. No, the baseball fields, where's the baseball field, guys? They're right over there. So it's not that way, it's that way. So the testing center is that way, right next door. There is no other building next door. It's the building next door. I'm saying I am directionally challenged, but I do know it's over there. All right, and you do have to have your own calculator, and there is some questions about the calculator you can use. Do any of you have a TI Inspire? You can't use that. Yeah, it's a really fancy, expensive calculator that I have my son owns one, but my son's getting a PhD in computer science. So it's a really, really expensive, nice, fancy calculator that is more complicated to use than I want to bother with. So you can use a TI-83 or a TI-84 or a TI-89. That's fine. But anything above that can it can actually probably do the test for you. But all right, are there any questions on that? I don't think any of you have taken it yet. That's okay. You have time. All right, any questions? Let's start talking about functions then. So we're going to start our 3-chapter discussion of functions today. We're going to look at functions in chapter 2. We're going to get the basics. Then we'll talk about polynomial and rational functions in chapter 3. And then in chapter 4, we'll talk about exponential and logarithmic functions. So we're going to first define what a mathematical relation is. And then from the definition of a relation, we'll talk about what the domain and range is. And then from there, we'll get the definition of a function. A function is just a special type of mathematical relation. And then we'll look at equations because if I were to spend the length of time I normally spend on talking about functions, I talk about the different ways you can define functions. There are multiple ways you can define a function, but if you're in algebra, typically you would define a function by an equation. So how do you know if the equation you're given is the equation of a function? It is so hard to figure out, she says, dripping with sarcasm. It is not hard to figure out how an equation is a function. Then we'll evaluate a function. We'll talk about plotting points. We'll talk about the vertical line test. We'll talk about getting information from the graph of a function. We'll talk about the domain and range from the graph of a function. And then we'll talk about intercepts. Okay, what is a mathematical relation? A mathematical relation is a set of ordered pairs. What's a set of ordered pairs? What's an ordered pair? An ordered pair is just two numbers whose order matters. And when we talk about ordered pairs, we're talking about points that we plot on the coordinate plane. The first number being the x coordinate and the second number being the y coordinate. So if I have an ordered pair 3, 2, that is the point on the coordinate plane that's 3 units in the x direction and 2 units in the y. So it's that point at 3, 2. 1, 2, 3. 1, 2. So it's that point right there. And it's called an ordered pair because the order that those two numbers occur in is important. The first coordinate is always x, the second coordinate is always y. So if you have a set of ordered pairs, the set that consists of all the first components of your ordered pairs is called the domain. So in a mathematical relation, set of ordered pairs, all the first components are the domain of that relation. And the range of that relation is all the second components, all the y values in your ordered pair. So a relation is a mathematical relationship between two numbers. It's a set of ordered pairs. All the first components are called the domain. All the second components are called the range. So that is a mathematical relation. It's a mathematical relation because it's a set. And how do I know it's a set? Because of the braces. If you got braces and you've got stuff listed with commas in between those somethings, that's a set, mathematically defined set. Okay? And each one of these, sorry about that. Come on, PowerPoint, don't help me. Each one of these ordered pairs is an element in the set. So this is a set of ordered pairs. The elements are what? 0, 9.1, 10, 6.7, etc. So what's the domain of this relation? What's that? Did you say just one number? What's that?
The range of the domain is 40.
Well, the range of the domain is 40. That's kind of funny. I like that. The domain actually consists of what, though? All of those numbers that occur in the first components. So the domain is the number 0, 10, 20, 30, 40. So it's the numbers 10, 0, 10, 20, 30, and 40. So it is the set that consists of all the numbers that are in the first components of my ordered pairs. So what's my range? Nine 9.1, 6.7, 10.7, 13.2, and 21.2. And it's really that hard to do. That's how hard it is to do. So the domain is all the set of first components in the set of ordered pairs. The range is the set that consists of all the second components in our set of ordered pairs. Okay. What's a function? Well, a function is a mathematical relation with a special property. And the property is that no first component can go to more than one second component. So in my set of ordered pairs, I can't have the same first coordinate going to two different second coordinates. So this would be a function. That would be a function because all the first components in my set of ordered pairs are unique. I don't have the same first component going to two different second components. Now I do have a 1 and a 2 both going to 1, but that's okay. I can have this different first components going to the same second component. What I can't have, so this is a function. What I can't have is this. Why is that not a function? You can't have more than one in the first component of a set of ordered pairs. Each first component must go to a unique second component, or no x can go to two different y's. No x can go to two different y's. You can't have the same x and two different y's. So this is not a function, as she said, because of this right here. I can't have one ordered with 1 and 4. That is not a function. One needs to be ordered with a unique value. So each x component maps to one and only one y component. Okay, so typically we define functions as equations, and this particular function is a function that actually is related to the set of ordered pairs we looked at earlier, which happens to represent or model the percentage of first-year college women claiming no religious affiliation as a function of time, where X is the number of years since 1970. So that particular function equation models that set of data that we saw earlier, the set of ordered pairs. So what's this mean? This means that in 1971, 1971 corresponds to X equals 1 because X represents the number of years since 1970. So 1971 would be X is equal to 1. And that is a function. How do I know that's a function? Because I'm telling you it's a function. What happens if you input an X? So she just used the word input. Ooh. What happens if you input 1 for x? How many y's do you get out? 1. So for every x you input, you get exactly 1 y output. Ooh, those are big words. So input represents what we put into the function, which would represent our x's, and the output is represented by our y's. And that is important because that's what functions do. Functions take some input and then it does something to the input. And then it gives you an output. What does that function do to your input? It takes your input and it squares it. And then it multiplies it by 0.01. Then it subtracts from that your input times 0.2. Then it takes that and it adds 8.7. So when you input 1, you output, I don't know, what do you output? Whatever you output. You can put that in your calculator and figure that out. So if my input is 1, I get an output y. So when you have a function, you get a set of input-output pairs where for every input, you get 1 and only 1 output. You only get 1 unique output for each input. Okay? So the variable x we call the independent variable because it's your input. It is what you input into your function. So y is called the dependent variable because it depends on what you input for x. The value of the dependent variable y is calculated after selecting a value for the independent variable x. But not every ordered pair, as we saw earlier, defines a function. If you have the same first coordinate going to 2 different second coordinates, that is not a function. If you have the same x going to 2 different y's, that's not a function. So not every equation that you see defines a function. How do you tell if the equation you're given is the equation of a function? It's really hard. That's not a function. How do I know that? I know. Can you solve that for y? Now, you just finished chapter 1, or should be finishing it up. Oh, as a hint, just saying, you should really do the chapter 1 exam review. Why would I say that? Well, number 1, it's a prerequisite to taking the exam. I just gave another test in another class, and I would say 70% of them just kind of looked at the review. Why wouldn't you do it? Does it look exactly like your exam? Yeah. The only difference between your exam and the review is we mix up the order of your questions. That's it. It's 18 questions. The exam's 18 questions. If you have to divide complex numbers on the review, do you have to divide complex numbers on your exam? Yep. If you have to solve a quadratic using the quadratic formula on the review, do you think you have one of those on the exam? Just saying. All right. You're going to solve this for y. So I learned in chapter 1 to move that x squared over there because I'm solving for that. So I'm going to do that by subtracting it from both sides. And I learned that I can take the square root of both sides. I can use the square root property. But when I do that, I need to put a plus or minus on the right-hand side of the equation. And when I take the square root of a square, I just get whatever I'm squaring. Okay, so now if I put in x is equal to 0, what do I get for y? So how many outputs do I get for y for that input of x equals 1? Can I do that with a function? No. Okay, so how do I just look at it and know it's not a function? What do you think is the telltale indication that that's not a function? Anybody guess?
It's not solvable.
Well, it is solvable. I solved it, but it took me a little bit of work to solve it. What's the exponent? What's that?
You have to square root it. If you have to square root it, it's going to end up.
So you're both getting to the same thing, because what happens is it doesn't look solvable, but it is. When you solve it, you have to put the plus or minus in there. And why do you have to put the plus or minus in there? Because the y has a exponent of 2 on it. So as soon as y has an exponent of 2, when you solve for y, you got to put a plus or minus and take the square root. So if the exponent on y is what? An even number, that's going to happen every time. So if y is even, the exponent is even, you're going to have to take a root, an even root, and you're going to have to put a plus or minus in front of it. So what makes it not a function? If the exponent on y is even, then it's not a function. That's all you have to do. All you have to look at. If it's odd, are you okay? Yes. If the exponent on x is even, are you okay? Sure. When is it not a function? If the exponent on the y, the variable you're solving for, is an even number. Because if it's even, you're going to have to do the plus or minus thing and take the root. Okay. Function notation. The nice thing about function notation, if you have an equation written in function notation, it's a function. There's no guesswork on your part. If an equation in x and y gives one and only one value of y for each value of x, then the variable y is a function of the variable x. When an equation represents a function, the function is often named by a letter, such as F, G, or H, lower and uppercase. The one we use the most is F for function. But you can use any letter to represent a function, and you can use any letter to represent the input of your function. For example, anyone taking physical science, what's that represent? The velocity function as a function of time. So you can use any letters that you want. The special notation f of x, so f parentheses x, is read f of x or f at x, and it represents the output of your function at a given input x. So x is your input, f at x or f of x is your output. So if before we said x is your input and y is your output, are y and f of x exactly the same thing? Yes. F of x and y represent exactly the same value. It is the output of a function for a given input x. Why then do we write it as f of x instead of y? Because you know it's a function. If you see this kind of notation, you know that what that equation is describing is a function. Where given an input, you can find an output. If I have the velocity equation in front of me with respect to time, if I know the time, I know the velocity of my object. Okay, so here is our function that we had earlier, the percentage of first-year college women who claim no religious affiliation in the United States. We defined that function using the variable y equals 0.01 x squared minus 0.2 x plus 8.7. Since we know that's a function, we can replace the y with the notation f of x. Now, the other nice thing about this notation is when I write something like this, what does that mean? That means to find the output of my function when my input is 4. So when x is 4, figure out what y is. Input 4, output is f of 4. So my input is 4, and f of 4 is my output. And f of 4 is that y value when you evaluate that function at 4. Okay, so for example, what if you want to evaluate this function at f of 30? Well, let's pause and ponder a minute. What does x equal 30 mean? If x is the number of years after 1970, x equals 30 would that be 1970 plus 30? Is that the year 2000? So you're finding the percentage of first-year college women who claim no religious affiliation in the year 2000. So this model is going to predict a percentage of college women who claim no religious affiliation. So how do we calculate this? Well, our function is defined as f of x equals 0.012 x minus 0.2 x plus 8.7. So if we evaluate this function at 30, it literally means replace the x with the number 30. So you're going to take 0.012 times 30 squared minus 0.2 times 30 plus 8.7. And you take your handy dandy calculator out and you get 13.5. So what does this predict? This predicts that in the year 2000, 30 years after 1970, the model predicts that 13.5% of first-year college women will claim no religious affiliation. If you look at the PowerPoint slides that are in Canvas, you can actually see what this data looks like. They actually took the data and they show you a bar chart and what happens with this bar chart and why the equation that models that data looks the way it does, because it does this. So in 1970, there were a bunch of women, and as the years have gone on, it's steadily decreased. And it's decreased by a model that is quadratic. And that's quadratic because of what? That right there. So if my input, if the largest exponent on my input is 2, that's a quadratic equation, correct? That's quadratic, which we learned in chapter 1. So in the year 2000, my model predicts that 13.5% of women will claim no religious affiliation, first year college women in the United States. Okay, now, if a function is a special set of ordered pairs where no first component, no x, can go to more than one y, it is still a set of ordered pairs. And what can you do with a set of ordered pairs? You can plot them on the coordinate plane. Did you do that in chapter 1? So if I can plot a set of ordered pairs on the coordinate plane, I can draw a picture that represents all the ordered pairs of that particular equation. So can you graph a function? The answer is yes. Can you graph it on your calculator? The answer is yes. Because that is what your calculator graphs. It graphs functions. If you go to your y equals on your calculator, it says y equals. Well, what's y? Y is the output of your function. So y is a function output. It's an f of x. That is what it is. So for example, the graph of f of x equals 2x is the set of points x, y in the rectangular coordinate system that satisfy the equation y equals 2x. Well, what would that be? It's going to go through 0, 0. It's going to go through what? Let's do a couple. It's going to go through -1, -2. It's going to go through 1, 2. So if I draw this by plotting a few points, that is the graph that represents all the ordered pairs that satisfy that input-output relationship, f of x equals 2x. Are there an infinite number of ordered pairs that satisfy that equation? Yes, I just plotted 3. So what's its domain? Let's go back. What's the domain of this? If my data starts at 1970, what's my domain? Does it start at 0 and go? I don't know where it goes to. So does my domain start at 0 and then continue? I don't know. There may be a limit to what this model can predict. It's real world data. So maybe the model breaks down after the year 2030. I don't know. But real world data, you have to look at that kind of thing. You have to determine, okay, my model is predicting a real life situation. Does my model have its limitations? It very well could. But what about this? Is there any limitations on the domain? Is there any x you can't plug in and multiply it by 2? Can you think of any number in the real number system? We're talking about functions. And now that we're in functions, we're only going to be talking about real numbers. We're going to leave the complex numbers out of the equation because when we're talking about the coordinate system, the xy system, those are real numbers. There are not complex numbers in the coordinate system. Okay, what's the domain? Anything. So what's the domain? How do we represent all real numbers? Everything? What's its range? The range is the set of second coordinates, the set of y components. So what's the range? What's that?
Do the same thing.
Same thing. Because is there anything that you can't output for a given input? And the answer is no. And the other clue here is what the arrows are doing. We'll talk about that some more here in a minute. So the domain and range of that particular function is a set of all real numbers. Okay? So if, by definition, a function is a mathematical relation, which is a set of ordered pairs, where no x can go to more than one y, no first component can go to more than one second component, then we can, from that information, derive what is called the vertical line test. That is not a function. And it's not a function because of these three ordered pairs. Well, there's more than three ordered pairs, but these particular three ordered pairs we can look at. This relation, because it is a relation between a set of ordered pairs, and we can graph that relation to show the infinite number of ordered pairs in this relation. But it's not a function. And it's not a function because I have 0, -1 as an ordered pair on the graph of this relation. Also, I have the ordered pair 0, 0 as an ordered pair on the graph of this relation. I also have 0, 1 as an ordered pair on the graph of this relation. I have three first components 0 going to three different second components 1, 0, and -1. I can't have an x going to more than one y. That's not a function. It is a relation, but it's not a function. So we come up with this test called the vertical line test. The vertical line test says, if I can draw a vertical line is straight up and down, correct? That's vertical. If I can draw a vertical line through the graph of a relation and hit the graph in more than one place, it's not a function. Because if you can hit it in more than one place, you have the same x going to more than one y. Not a function. All right. So the vertical line test says, if any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So is that first graph a function or not? No. You're shaking your head no. Why is it not a function?
Because they're twice.
It hits the graph twice. It fails the vertical line test. The vertical line intersects the graph in more than one place. That is not a function. Is the second one a function? You're nodding. Yes, it is. Because no matter how many vertical lines I draw, I'm going to only intersect that graph in one place. That is actually a very, very common standard function. It's the standard quadratic function. So the first one, not a function. Second one, a function. Okay, you can obtain information about a function from its graph. At the right or left of a graph, you will find either closed dots, open dots, or arrows. So on each end of the graph, you're either going to have a closed dot, an open dot, or an arrow. One of the three on each side. A closed dot indicates that the graph does not extend beyond that point. That is an end point. And the point belongs to the graph. So if it's closed, that is an endpoint. that is included on the graph. It actually is a point on the graph of your function. So it's an endpoint that is on the graph. An open dot indicates that the graph does not extend beyond that point. It is an endpoint, but it's not included on the graph. So if you have an open dot, it's an endpoint not included. That is not on the graph. So if you're talking about writing domains and ranges, if it's a closed dot, you're going to use a bracket next to it. If it's an open dot, you're going to use a parenthesis. Included, we use brackets, remember? Brackets. If we use an open dot, we use what? Parentheses? All right, if you have arrows, what do arrows mean? It continues on. So if you have an arrow pointing to the left, it means it continues on in the negative direction. If you have an arrow pointing to the right, it means it continues on in the positive direction. And I don't want to say that you make this hard, but boy, howdy, do you make this hard. All right, so use the graph to find f of 5 for what value of x is f of x equal to 100. Okay, so let's talk domain and range before we start talking anything else. What's the domain of this particular function? And it is a function, it passes the vertical line test. What's the domain? Where does the graph of this function start in the x direction? Because domain, remember, is first coordinates. Domain is x's. Domain is horizontal. So where does the graph start? Starts at 0. And I'm going to use a bracket. Why am I using a bracket? Because I have a solid dot. So is there a point in my data that's 0, whatever that is, 1150, whatever it is? Is there a point in my data, 0, 1150? Yes. Where does my graph end in the x direction? Does it end at 11? So is my domain 0 from 0 to 11? And did I use brackets because each end of my graph has a solid dot? Okay, here's the tricky part. What's the range? Now, am I going to have to estimate the range? And the answer is yes, because my vertical scale is not near as precise as my horizontal scale. My horizontal scale is fairly precise, 0 through 11. So I'm pretty good there. The vertical scale goes from 0 to 100 and 1200, I guess it goes. But where does the dot go? I don't know. Where's that tall dot? I said 1150, maybe, approximately. And what's this little dot down here? What do you think that is? Oh, I don't know. Maybe 50? Maybe. I am purely and 100% estimating that. So what's the range? Both domain and range must go in numerical order. So it has to go from smaller to larger. So domain goes from left to right. Range goes from smallest to largest. So what's my smallest value? Approximately 50. What's my largest? Approximately 1150. And those are approximates. I approximated those from the graph. Okay? What's f of 5? What's that mean? Does that mean to find the output when the input is 5? So when the input is 5, what's the output? 400? Estimate that it's 400? Does that look right to you? Okay. what is x if f of x equals 100? What's that mean? Find x when y is 100? Where's 100? Right here? Oh, that's terrible horizontal line there. Maybe 9? Does it look like f of 9 is approximately 100? So the first one, they give you the x, they want you to find the y. So you go to that value of x, you go up to where it intersects the graph, you go over and figure out what the y value is. The second one, they give you the y value, and they want you to find the x. So you go up the vertical scale to that value of y, cross horizontally across to where you intersect the graph, and that's the x value. Okay, we've talked about domain and range. We've talked about this. Domain is the set of inputs. It is where your graph begins and ends in the horizontal direction. Range is from the minimum vertical value to the maximum vertical value. So this is where we get kind of confused. Domain, you pretty much got figured out. Range can have some issues. But this particular graph is perfect for demonstrating how the range works. The minimum value for y is right there, right there. That is the minimum y. And the maximum y value is right there, because this graph does what? It comes up to that maximum value, and then it starts going back down. So this is the maximum y value. So the range is going to go from that minimum y to that maximum y. Okay, so what's the domain of this function? Where does it start in the x direction? -2. Where does it end? 1? Do I put a bracket or parenthesis next to the -2? Why do I put a parenthesis? Because it's an open dot. Do I put a bracket or a parenthesis next to the 1? Bracket. Why do I put a bracket? Because it's a closed dot. Okay, what's the range? What's the minimum value for y? -1. Very good. Whoops. What's the maximum value for y? Do I put a bracket or a parenthesis next to the -1? Why do I put a bracket? Because it's a solid dot. Do I put a bracket or parenthesis next to the 2? Parenthesis. Why do I put a parenthesis? Because it's an open dot. So domain, smallest x value to largest. Range, smallest y value to the largest. So range is vertical. Domain is horizontal. Okay, intercepts. To find the x-intercept, you look where the graph crosses or touches the x-axis. A y-intercept, you look where the graph of your function crosses or touches the y-axis. A function can have more than one x-intercept. A function cannot have more than one y-intercept. If it has more than one y-intercept, it fails the vertical line test, touching the y-axis in more than one place. That's a failure of the vertical line test, so it's not a function. All right, more on graphs. Let's talk about functions that are increasing, decreasing, or constant. Let's talk about maximas and minimas. And this book uses relative maxima or minima. Some books use, what's the other word that they use? Oh, now my brain went dead. I can't remember what it's called. But we use relative. We're going to look at symmetry. We'll talk about odd and even functions. We'll talk about, as much as we can, piecewise defined functions. If I don't get through that, I do have a video that explains that. and we'll talk about the difference quotient, which I probably should do first. Let's make you dizzy. We're going to do the difference quotient first because it's that important. We're going to go out of order. When speaking with professors and PhDs at senior colleges in the state of Oklahoma, they say the most important thing that college algebra students need to learn is the idea that functions can change. And that kind of sort of makes sense, that if I input a value of my function at, one value, and then I input it use another input, that I get two different values for the function. So it kind of makes sense. But they say that we fail miserably in getting that point across to students. Okay, why do you need this? Because this is 100% pertinent to the first chapter in calculus. Now, whether or not you're STEM students, I'm assuming you are, because you're taking college algebra. And college algebra is that base course for you to continue in STEM. You'd take trig next, then you would take calculus. That is my assumption. Trig is all about functions. That's all that course is about functions. Okay, so what does this represent? This represents the rate of change of a function from a point to a point. What do I mean? Let me draw a picture of a function. I don't know. Let's just draw something. That's a function. It's going to pass the vertical line test. Would you agree? Okay. And this right here, let's call that x. So this right here, is that f of x? So this point right there is f at f of x, f of x. That's what it is. Correct? If an x component is x, then if I evaluate that function at that value, I get the y value, f of x, in the ordered pair that's on the graph of that function's x, f of x. Okay, now I'm going to go ever so slightly, use your imagination, to the right. This is going to be x plus h. And what's h? H is an itty bitty, teeny weeny, small number. So just ever so slightly to the right. Okay. Then this point here is x plus h, f at x plus h. That is what it is. Can you find the slope of a line that connects 2 points? Sure. How can you find the slope of a line that connects 2 points? Do you remember? Do you find the change in their y values over the change in their x values? Okay, so what is the slope of a line that connects those 2 points? So I got a slope, I got a line that connects those 2 points. What's the slope? Is that f of x plus h minus f of x, the change in the y values over the change in the x, which is x plus h minus x. What happens to the x's in the denominator? So what is this? It's the slope of a line connecting 2 points on a function. That's all it is. That's all it is. Why is that important? Because it's called the derivative. What's the derivative? It's the instantaneous rate of change of a function at a point. Why do we care? Well, because that's how we figure out if you shoot an arrow in the air, what's its acceleration going to be as you release it? How far is it going to travel? Can I figure that out? I can. Cool. Okay. So all that information given, if I have a function, how do I figure out what the difference quotient is? So the difference quotient is going to be the rate of change from some point x to some point x plus h. This is what I do. So the first thing I do, first step, is to find f of x plus h. Find the output if the input of my function is x plus h. Well, how in the world do you do that? So my function is negative 2x squared plus x plus 5. How do I figure out what that function is at x plus h? Do I replace the x with an x plus h? Can I do that? Sure. As long as it's in the domain of my function, can I input it to my function? And the answer is sure. So if you can input 2 into that function, can you input 2? Can you input 2.000000001? Sure. So what does x plus h represent? X, 2, plus a little bit teeny weeny more. So how do you do that? Where there's an x, you replace it with x plus h. And then you have to do some algebra. So I have to square x plus h. I have to multiply it by negative 2. And do any kind of combining like terms that I can do. And there's not any like terms I'm going to be able to. So I am going to cheat. And I am going to square this because I know how to square binomials. How do you square a binomial? You take the first term in your binomial and you square it. So you take the x and you square it. Then what do? You take the two things inside parentheses and you multiply them together. So you take the x and you multiply it times h. And then you multiply that by 2. So the middle term is always the two things multiplied together times 2. Always. Always. Promise. I promise you. I swear. It's always 2 times the product of the two things. So is that 2 times xh? Then what do? You take the second thing, the h, and you square it. So what's inside those parentheses is that binomial squared. It always works that way. Always. Isn't that convenient that it always works that way? That it's so predictable? That anytime you square a binomial, that's exactly the way it works? Isn't that nice? You square the first thing, you multiply the two things together, and multiply that by 2, and then square the second thing. Okay, then what do we have? We have the x plus h, and then we have the 5. Now we're going to take the negative 2 and distribute it across. So we have negative 2 x squared minus 2 times 2 is what? Minus 4 xh minus 2h squared plus x plus h plus 5. Now, that is the function evaluated at x plus h. And it looks long and ugly, but it's not that big of a deal. So now what I'm going to do is I'm going to subtract the original function from all that mess. So I'm going to take all of this. We're going to take all of this and we're going to subtract negative 2x squared plus x plus 5. So we're going to do that. We have negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5 minus 2x squared, I ran out of room, plus x plus 5. Okay, and when you subtract something inside parentheses, what happens? You change the sign of everything on the inside of the parentheses? Is that the way you do that? Yes. So what are we going to do? We're going to change that minus 2x squared to plus 2x squared. We're going to change that plus x to minus x. We're going to change that plus 5 to minus 5, and then we're going to subtract it. Or we're going to add it, excuse me. And if you've done this correctly, what's going to happen? If you've done this correctly, what's going to happen is that entire function is going to subtract off. If you've done it correctly. So do I have negative 2x squared and x squared? Is that 0? Do I have plus x minus x? Is that 0? Do I have plus 5 minus 5? Is that 0? So what you're left with is only terms that contain an h. So what am I left with? The negative 2x squared and 2x squared add to 0. So I have minus 4xh minus 2h squared. The x minus x add to 0 plus h plus 5 minus 5 is 0. So what am I ending up with? Negative 4 xh minus 2h squared plus h. And then what do I do with that? I divide it by h. So I have negative 4 xh minus 2h squared plus h, and I'm going to divide that by h, and I get the difference quotient. That's the slope. Remember, that's the slope of the line connecting those 2 points, x plus h and x. Okay, what happens if you divide that by h? Will an h cancel from each of the terms? Will an h cancel here? Will an h cancel there? Will that h cancel? So what do you end up with? I've got a big mess here. Negative 4x minus 2h plus 1. Negative 4x minus 2h plus 1. That's the derivative. Well, sort of. What happens as h gets infinitely small? And that's what you're doing, right? You have an x here, and then you have an x plus h, which is infinitely close to x. So what happens as h gets smaller and smaller and smaller and smaller and smaller and smaller and smaller? It goes to 0. Correct? As a number gets smaller and smaller and smaller and smaller, does it approach 0? So what happens if h is 0? Do you get negative 4x? Do I have a negative in front of it? Messy negative. Do you get negative 4x plus 1? That's the derivative. That's the derivative of that function. It's the instantaneous rate of change of that function. Can I evaluate the instantaneous rate of change of a function at a point? Sure. Can I evaluate that when x is 2? Sure. That's the slope of the line that's going through that point of that function at that time. So did you just do your first lesson in calculus? Yes. Anyone going to take calculus? Business calc? This is the first thing we do after we review functions. We always review functions in calculus because you need that little bit of review after algebraic functions, especially because it's been, a couple of semesters since you looked at algebraic functions. So we always do this first. We look at functions and then we look at the difference quotient because that's like the fundamental definition of calculus. All right. And do professors at universities think this is important? Boy, howdy, yes. And we'll talk about this some more later. All right. Back to where I was. Increasing, decreasing, and constant. Boy, do you make this difficult. I'm not kidding. Okay, first of all, when you describe if a function's increasing or decreasing, you describe it over its domain. So you say, the function is increasing over x from 3 to 5. So you always talk about it increasing or decreasing over the domain. It's never the range. It's always the domain. So it's decreasing from 3 to 5 in the x direction. It's increasing from 4 to 6 in the x direction. Okay, what does it mean for something to be increasing or decreasing? If it's going up, it's increasing. If it's going down, it's decreasing. Up, increasing, down, decreasing. Constant means it's horizontal. You never use brackets when you describe increasing or decreasing. It's always over an open interval in the domain, which means you always use parentheses. So somewhere put in your mental, put it in there somewhere. If I'm describing the interval over which a function is increasing or decreasing or constant, I will not use a bracket because it's wrong. Okay. So what are relative minimas and maximas? The definition of a minima is that on each side of that minima, the function value is larger than it is at that particular value. So if this is some number b and the y value is f of b, on each side of that, the y value is larger. That's the definition of a minima. Okay, what's happening here though? To the left of that minima, what's your function doing? Going down. It's decreasing. It's coming down. It's decreasing. It hits that point. It hits a minimum. Then what's it start doing? Just going back up. So what is it doing? It's decreasing to the left of that minimum. So this particular function is decreasing from negative infinity to b. It's decreasing. It hits the point b, it's at its minimum, and the minimum value is the f at b. So minimum values are y values, but it's decreasing to the left of that minimum. And then what's it start doing? Starts increasing, starts going back up. So it's increasing, decreasing here. It starts increasing from what? B to A. So to the left of a maxima, it's increasing because it's coming up. Then what's it do? It hits whatever that maximum value is, and what's it start doing? Starts decreasing again. So is it decreasing from A to infinity? That's what maximas and minimas are. on each side of this maxima, the y value is smaller than it is at that maximum. Functions are decreasing, they hit a minimum. They hit that minimum value, they start increasing again. They go to a maximum value and then they start decreasing again. Minimums are valleys in your graph of your function, maximas are hills. Okay? So what is this function doing? Well, it's labeled already for us that there is a relative maximum at pi over 2, 1. Does anybody know what this function is? Anyone take trig in high school? None of you took trig in high school? How did you get out of high school without taking trig? Really? I'm shocked and appalled. I took through calculus in high school. And I went to a really mediocre high school. I got 3 minutes. I went to Star Spencer, which was mediocre then. Now it's got 200 people in it. It's like nobody is in the school. It was like, I graduated with a class of 350. They're not even 350 students in the entire school there now. And I took calculus. Anywho, that's a sine function. Now you know it's a sine function. Okay, and it has a minima at negative pi over 2, negative 1, and it has a maxima at pi over 2, 1. What's pi? Pi is that number 3.14 or whatever. Okay, so what is it doing? To the left of that minimum, it's decreasing. We're always decreasing to the left of minimums. So it's decreasing from negative infinity to negative pi over 2. At negative pi over 2, it has a minimum of negative 1. Then what does it start doing? Then it starts increasing, correct? And it increases from what? Negative pi over 2 to pi over 2? It's going up. And then what's it do? It hits that maximum, and the maximum value is 1. And then what does it start doing? Does it start decreasing again? So it decreases from pi over 2 to infinity. So it's increasing from negative infinity to, decreasing from negative infinity to negative pi over 2. It increases between negative pi over 2 and pi over 2. Then it starts decreasing again. All right, are there questions? I'll post the video that I have for the remainder of this section, so you can view that video if you desire. There's lots of videos in Canvas. If you haven't been in Canvas lately, there's lots of videos in there. In section 2.2 in Canvas, there's a slew of videos you can watch. Are there any questions? Okay, I won't see you again before the test is due. When is your test due? Friday. All right, good luck. Talk to you next week.